Continuing on in lesson 6.2 here, sometimes we don't have the x-intercepts falling at integers, positive or negative integers. Sometimes you have to estimate in between integers. So that's what we're going to look at here in this example. We're still going to do everything pretty much the same as far as find the middle of the parabola, middle of your table, graph the parabola, but then we have to state the consecutive integers between which the roots are located, because they're not going to be at integers on the x-axis. So notice if we look at the quadratic equation, into y equals, I'm going to plug in x squared minus 6x plus 3. But before we do that, let's do our axis of symmetry, or the middle of the parabola. Let's do negative b over 2a. So the opposite of negative 6 would be 6, all over 2 times 1. 2 times 1 is 2. So my axis of symmetry is going to be at x equals 3. So it's right there. Okay, so that means when I make my table, I know I have to put 3 in the middle, because that's where my vertex is. So let's go ahead and plug in x squared minus 6x plus 3 into our table, or into our y equals first to get our table. So I have x squared minus 6x. So I'm going to just arrow over and type in a 6 there. And then I'm going to arrow over, and we want plus 3 instead. So x squared minus 6x plus 3. Now let's go ahead and grab our table. And in the middle of our table, remember we wanted 3. So looking at your table, if you have that on your calculator, at 3, it's at negative 6. I'm going to put 3 values on the other side here. At 2, we're at negative 5. At 1, we're at negative 2. And I'm just pulling these from the table on my calculator. I'm not going to go back and forth here on the video. At 0, we're at 3. At 4, we're at negative 5. At 5, we're at negative 2. At 6, we're at 3. Now you may ask, why did I go 3 x values on the other side and 3 x values on this side? And there's a reason for it. Okay, if I only went from here to here, notice we'd still be down in the negatives for our y values. Okay, so I went further because now here we got a positive y value when x was 0, and here we got a positive y value. And there's a reason for that, because that's going to help us state the consecutive integers. So let's plot 0, 3. Let's plot 1, negative 2. 2, negative 5. 3, negative 6. 4, negative 5. Whoops, I only went down to 4. Let's fix that. Let's actually fix that. My mistake there. At 2, so at 1 we're at negative 2. At 2 we're at negative 1, 2, 3, 4, 5. So we're down here. At 3 we're at negative 6. At 4 we're at negative 5. 5 we're at negative 2. And at 6 we're up here at 3. So this half of the parabola goes like this. Oops, I didn't get all the way through there. And this half goes like this. Okay? So as you can see, where does it cross the x-axis? We're looking right there, okay, because it went from a negative up to a positive. So from when x was 1 back down to x is 0, and right there. So between what integers? Here's where we're going to do the estimated roots. And we're just going to state the consecutive integers. We don't have to say, oh, it's about 3.4 or something like that. So if you notice, this is between an x value of 0 and 1. So we're going to say between 0 and 1, between an x value of 0 and 1 right here. And this is between between 5 and 6. This would be 5, this would be 6. So somewhere, notice it went from here, where it was in the negatives, up here in the positives. So the other one would be between 5 and 6. So that's how you state your solution. We don't have to say, oh, it's about 0.3 or 0.4. We can just say between what two integers. All right, last example here. And again, I don't think we assign in regular Algebra 2 trig, I don't know if we assign any word problems, but I'm going to go through this. I'm going to show you on the calculator how you can use this to figure it out. It says the highest bridge in the United States is the Royal George Bridge in Colorado. The deck of the bridge is 1,053 feet above the river. Below it, suppose a marble is dropped over the railing from a height of 3 feet from the bridge deck. How long will it take the marble to reach the surface of the water, assuming there is no air resistance? Use the formula H of t, just functional notation, equals negative 16t squared plus h0, where t is the time in seconds, h0 is the initial height above the water in feet. Okay? So, we need to find t when h0 equals, if you notice, we're 1,053 feet above the water below, and it's a height of 3 feet, so we need to actually do 1,053 plus 3, so that means my initial height above water will be 1,056. Okay, the 3 feet above plus the 1,053 feet above the river that the deck of the bridge is. So here's what we really have. H of t equals negative 16t squared, and it was plus h0, but we are really using then the 1,056 that came from that 1,053 plus 3. So we're going to go ahead into the graphing calculator and put, except for we can't put t's in, so we're going to put in x squared there instead. So this is what I'm going to put in my calculator. Negative 16x squared plus 1,056. We are going to have to adjust our window. And I'll show you how to do that on the graphing calculator. We're going to adjust our window. I'll talk about that here in a second. But let's go ahead and put in negative 16x squared plus 1,056. So let's go to y equals. Let's clear that out. So we're putting in negative 16x squared plus 1056. Let's hit enter so that that's in there. Okay. So basically we want to look at the intercepts. Okay, now we're really using x here, but x is our t, or our time. So we want to find the x-intercept. It's got x squared in it, so we know it's a parabola, but we're going to find, okay, when x is 0, which means when t is equal to 0. Because they're saying, how long will it take the marble to reach the surface of the water? So when will it be at a height of 0? Okay, so we want to find the x-intercept. So let's take a look at the graph here. So if I go back to my calculator, if you have it in your calculator, actually go to the window. We need to adjust here. Now if you notice, if we go back to this, we were at 1,056, which basically would be my y-intercept. So I've got to adjust my y's here. I can keep my x's going from negative 10 to positive 10. That's the time now. X is the time. I can keep that going from negative 10 to positive 10 in increments of 1. But we're going to adjust the y's. So I'll show you how to do that. So we're going to come down here. Let's hit the down arrow. We're going to go keep everything the same with the x's. But we're going to go from negative 100. And I know it doesn't make sense for the height to be a negative 100. Basically, a height of 0 would be on the surface of the water. But we're going to then go to a max. Now, the y-intercept's 1,056, so I'm going to go up to, let's say, 1,100, which is a little bit above that. Okay, now we don't want to go by a scale of ones from negative 100 up to 1100. Let's go with the scale up the y-axis going by hundreds. Okay. Now I'm not going to really pull up my table. I'm actually going to hit the graph button, which I haven't showed you a whole lot. My calculator's been showing the graph. So there's the parabola. Notice our y-intercept, okay, was right here. The parabola is symmetrical basically about the y-axis. Now we want to find the x-intercepts, which are here and here. Okay. Now x is the same as t or time. So we can't really have a negative time here. So we're really only looking at the positive. What positive value is that? If you actually trace, and we're going by ones across the x-axis, which is the t-axis in this case, if you actually trace that, okay, or if I hit my trace button, I got to close out my ink layer there, but if I hit trace, and I actually scroll over and follow this down with my right arrow, you can kind of see where we're at here. Let's go back one. Now it's not exactly, but basically it's at 8 seconds. Okay. So notice there at about, so we're down to the x-axis, and I would say to the nearest second or the nearest x value, it's about 8. Okay, so we're going to say that the time, the x-intercept is at 8, so that means that t is also equal to approximately 8 or about 8 seconds until that reaches the surface of the water.